Last time, we built the transformer, a factory that turns words into understanding. But we left out one critical detail. When this factory is brand new, every single weight inside it is random noise. Ask it to finish a sentence and you get garbage. Random weights produce random outputs. So how does this pile of randomness become something that can actually think? That's training. Training is built on one simple game. Show the model a chunk of text with the last word missing and ask, what comes next? The model guesses. At first, badly. Maybe it thinks elephant is more likely than mat. It's wrong. But here's the key. We can measure exactly how wrong. That measurement is called the loss, a single number. High means the model is clueless. Low means it's getting close. The entire goal of training is to push that number down. Now think of it this way. Every possible combination of weights puts you at a different spot on this landscape. The height is the loss, how wrong the model is. Peaks are terrible. Valleys are good. Training means finding the lowest valley. But there's a catch. You're a hiker on this landscape and you're blindfolded. You can't see the valleys. You can only feel the slope right under your feet. So you do the only thing you can. You feel which direction is downhill, and you take a step. Then you feel again, and step again. Feel the slope, take a step. That's it. Engineers call it gradient descent, but it's literally just walking downhill. Step by step, the model slides downhill. Each step adjusts the weights a tiny amount. Each adjustment makes the predictions a little less wrong. Millions of steps later, the model lands in a valley where the loss is low and the predictions actually make sense. But here's the problem. The model has billions of weights spread across dozens of layers. When it gets a wrong answer, which weights are to blame? The factory plays the blame game. The error signal flows backward through every layer, from the output, through the feed-forward networks, through attention, all the way back to the embeddings. Every single weight gets a blame score. How much did you contribute to the mistake? Engineers call this backpropagation, but it's just pointing fingers layer by layer. And then each weight gets nudged, just a little, in the direction that would have made the answer less wrong. That nudge, that's one step of training. How big should each step be? That's the learning rate, and it matters a lot. Too big and you overshoot. You bounce right past the good valleys. Too small and you barely move. Training takes forever or you get stuck. Just right and you glide into the valley. In practice, models start with bigger steps and gradually shrink them, like taking bold strides on open ground, then careful footsteps near the edge. So that's one training step, one sentence, one guess, one correction. But how many steps does it actually take? Models don't learn one example at a time. They process thousands at once. That's a batch. Each batch gives one weight update. And they do this millions of times. Imagine a factory the size of a city. Tens of thousands of machines running day and night for 3 months straight, reading every book, every website, every conversation they can find. The electricity bill alone runs into the hundreds of millions of dollars. But more training isn't always better. There's a trap. Train too little, and it's like a student who skimmed the textbook. It gets the gist but misses everything specific. It draws a straight line through a curve and calls it a day. Train too much on the same examples, and it's like memorizing the answer key. It aces the practice test, but falls apart on anything new. Every quirk, every typo, every bit of noise. Memorized, not understood. The goal is the sweet spot. Learn the real patterns, ignore the noise. This balancing act is one of the hardest parts of training. One last thing. Training isn't actually one step, it's 3. First, pre-training. Read trillions of tokens from the internet. Learn language, facts, patterns, reasoning. This is the big expensive step, and it produces a model that's fluent but has no manners. Then, fine-tuning. Train on curated examples of helpful conversations. This teaches the model to actually be useful, to follow instructions and answer questions. And finally, alignment, where humans rate the model's outputs and the model learns what helpful, honest, and safe actually look like. Alignment is where AI learns to be helpful instead of just smart. That's its own story. That's how AI learns. Embeddings give words meaning. Training decides what that meaning is. Tokens break text into pieces. Training teaches what each piece represents. Attention lets tokens talk to each other. Training teaches them what to say. The transformer is the factory. Training is what brings it to life. Next time, the factory is trained. The weights are set. Now someone types a question and hits enter. How does the model actually generate a response, one token at a time? That's inference. See you there.